Hello and welcome to my channel. Dear friends and students, the presentation is about the famous 7 bridges of Konigsberg problem. Konigsberg was capital of East Prussia until 1945, then it was conquered by the Soviet Union and renamed as Kaliningrad. In the image shown, you see the current map of city of Konigsberg with River Pregel flowing through it. We can see 5 bridges there, but initially there used to be 7 bridges. The 2 bridges in the leftmost side were actually 4 earlier. Now there are only 5 bridges left. This is actual view of Old Konigsberg. There was a question in the minds of citizens of Konigsberg. Is there a walk possible in which each bridge is passed exactly once, starting from any place in the city? Let me show some ways they tried to discover such walks, but each time they failed. Either one bridge was left or a bridge was passed more than once. When they found it difficult to answer, they decided to ask famous Swiss mathematician Leonhard Euler, and they wrote a letter to him. With his scientific approach, Euler decided to try the problem on paper rather than wasting time in running here and there on the bridges. That's what the great mathematicians do. Euler selected 4 land areas and marked them A, B, C, and D. He then joined these points through 7 arcs, each arc representing a bridge, and obtained this kind of a sketch. He called A, B, C, and D as vertices and the arcs as edges. And the diagram he renamed as a graph. By that time, he had understood that the desired walk in Konigsberg is possible if and only if the corresponding graph can be traced on paper without lifting pencil or without going over a line once drawn. I show this side by side that walking through the bridges is similar to drawing the corresponding graph. Now let us see some graphs which are traversable, that is, they can be drawn without lifting pencil or without going over a line once drawn. Euler found in number of attempts that graph corresponding to Konigsberg was not traversable, but he wanted to prove it mathematically. During his investigation, Euler defined an even vertex and an odd vertex. An even vertex is that vertex which has even number of arcs connected to it. Finally, he proved that a graph is traversable if and only if it has either no odd vertex or only 2 odd vertices. This first graph has no odd vertex. This second one is traversable, it has 2, and the third one is also traversable, it also has 2 odd vertices. Let us understand the proof. Suppose you want to trace a network without taking your pencil off the sheet or tracing any edge twice. The vertex from which you will start will be an odd vertex and will remain odd unless it is also the ending point. Now there are two possibilities. Starting point is also ending point. In that case, all the vertices will be even. And if the starting point is not the ending point, then exactly we will have two odd vertices. Since the network corresponding to Konigsberg had 4 odd vertices, hence Euler proved mathematically that the graph is not reversible and desired walk is not possible. A similar problem is of New York City bridges and tunnel problem. In the corresponding graph, there are 2 odd vertices, B and D. Hence, desired walk is possible provided starting and ending point are B and D. Thanks for watching this video. Please like my video and subscribe my channel for upcoming videos. Thanks a lot.